Good morning to one and all. I am Parthiban, working as an assistant professor in the Department of ECE, Sri Muthukumar Institute of Technology, Mangadu, Chennai. Now I am going to talk about the subject called satellite communication, which is coming under the regulation R 2021. The subject code is CEC 352. Now I am going to talk about the Unit 4, particularly about the various multiple access systems and its effects. In the last class, we have seen about the FDMA, TDMA and CDMA very clearly and elaborately. Why we go for CDMA? That and all we have discussed here. Now there is a trade-off that is existing between the frequency band and the satellite communication system. So if you go for CDMA, the frequency needed may be quite higher, but it will provide all the needed features, but at the cost of frequency or bandwidth we can say. So we have to compensate for the bandwidth, but at the same time we have to improve the number of also. So the most attractive portion of the radio spectrum for satellite communication lies between 1 gigahertz to 30 gigahertz range. So the relationship of frequency, bandwidth and application are very important because these three things are correlated with each other. So generally the focus is on the frequency band trade-off as well as the practical operation of TDMA protocol as well as about the practical operation of Aloha protocol, actually about the performance comparison of TDMA and Aloha. These topics are extremely important because they influence the design, efficiency, delay and capability of modern VSAT as well as satellite communication networks. What is meant by frequency band trade-off? Actually, a satellite communication is a form of wireless communication that uses RF spectrum. Since the spectrum is very limited, it must share the resources with other services also, such as mobile communication, television broadcasting, radar systems, navigational system, military communication, as well as for wireless networking. So within the frequency band, we have to accommodate all these types of uses. So the choice of frequency directly affects the system capability as well as the antenna size, as well as the equipment cost, as well as the signal quantity, as well as quality, as well as the rain attenuation. So these are the prime factors that we have to take into consideration. So before going into the modern situation where we need a broadband net, direct to home television, where mobile backhaul, where military communication latest, we have to cater the IoT networks also. All these services has to be provided within the available bandwidth or spectrum. The frequency allocation can be made within the available spectrum only. This has become an international issue for all the governing bodies. So the satellite communication mainly operates between the 1 gigahertz to 30 gigahertz capability only. So below 1 gigahertz, we need a very large antenna, a limited bandwidth with the heavy spectrum congestion that is all. If we go for above 30 gigahertz, the problem we will face will be a severe atmospheric absorption, heavy rain attenuation, increased equipment complexity as well as higher cost. So there is a relationship between the frequency and bandwidth that we have used. So thing should be governed particularly to accommodate the trade-off so that we can have all the advantages of satellite communication in mind. So the factors that affect the frequency band selection primarily the available spectrum, the link distance, the weather conditions and the traffic requirement as well as the cost also. These things should be kept in mind before designing the multi-access system. So the operation of multiple access protocol Particularly the TDMA with its frame format is given in the diagram. So it shares the timing. So from this diagram we can see the time was divided and it has been used. So there are various blocks that are available, particularly the preamble block as well as the user data block. So under which so many subdivisions are there. There will be some reference bus that is also there. So TDMA is nothing but the same frequency, same satellite, but with different time slot. So TDMA features that we have seen already, but the only thing it needed is synchronization is needed in TDMA. That's what the main drawback of TDMA. Also, there will be average delay that we used. So we have to accommodate the average delay also. Coming on to the TDMA throughput. So TDMA can achieve the throughput approximately about 90% efficiency. So losses can occur because of the guard intervals, because of the sync bits, because of the control information also. There is the operation of Aloha that we have already discussed. So Aloha is a random access protocol. Unlike TDMA, there is no central scheduling in Aloha. So the transmit independently, there is no need to wait for assigned signal or slots also. So Aloha was developed mainly with the objective of simplicity, low cost, fast access and minimal control. It is very well suited for bursty data traffic mode. Then we can subdivide the Aloha into slotted Aloha and pure Aloha. In the slotted Aloha, the time is divided into slots. That's why it is called slotted Aloha. So example is typically lies with the three VSATs that can be operated independently. We can able to transmit the successfully the data. So that is a typical example that we can go for the Aloha. Then coming on to next slide, that VSAT systems that remains idle until there is data to be transmitted. So VSAT 1 is the first needed channel, so it transmits the block of data without waiting. VSAT 2 transmits next independent of what happens to the users at 1 and 2 or 1 and 3. From the downlink timeline, we can see that VSAT 1 and 2 do not overlap and hence get together in a clear way. So the next packets from VSATs 1 and 3 has reached the satellite at the approximately same time, and so they have produced a collision. In the event of such time overlap, the signals jam each other, the information is lost. So this is the problem that we have to account. So the operation of Aloha depends on the packets and that are ultimately transferred through the automatic retransmissions also. So the delay between the original and retransmitted packets is selected randomly by each VSAT to reduce the possibility of second collision. So the result of this protocol is the time delay that is very small in nature but does not expect a collision. So in the operating situation, only 1 in 10 Aloha packets will experience such collision. So 9 packets can from the packet. So the diagram depicts the typical operation of multiple access protocol using Aloha. So here we can see the VSAT 1, VSAT 2, VSAT 3. Both uplinks are, all the uplinks are how it has been connected and how it has been retransmitted, that we can see. So in between there is a time sharing technique that we can see. So in this way the multiple access system will come into picture and the pure Aloha as well as slotted Aloha will do the job great. So with that I am winding up my lecture. Once again, thank you all.